Alright, so the issue was brought up during a roundtable recently about how to set point variables. So these right here that you create in either Test Commander or GI.Bench on your q.stations. I hadn't ever actually done this myself, and so I finally got around to experimenting with it and setting it up, seeing how it works. Got some help from a customer and thought I would make a quick video just sharing what I found out as I was doing it. So I'm going to start with Test Commander because my particular hardware has eBlocks modules on it because they're hand-me-downs, and there's a fun, interesting quirk with the latest firmware on Gantner q.stations where they are compatible with E-series I/O, but you have to do certain things in Test Commander as opposed to GI.Bench. There's a lot of things with the E-series that you can't do in GI.Bench. I'm not sure you can do anything at all with them actually. So anyway, I'm going to start this in Test Commander and then I'll hop over to GI.Bench later. But so here's just a simple small setup. I've got some analog inputs down here, some analog outputs. My analog output channel 1 is actually wired to my analog input channel 1 so that I can move it around. And then I've got some of these virtual variables that we were talking about in the discussion. Now, I don't think that you're going to be able to talk to these using eBlock server. Maybe you can and you've figured it out. I never tried because I don't love the attribute layer to begin with. So these you can read them via the default underscore eBlocks if eBlock server is running. They'll just stream by default, but you can't write to those using that method. So what you can do is write to them using gmodbus. And I was pleasantly surprised to find out that it's very easy to get the modbus registers. In Test Commander, you simply press that button. The statistics button looks kind of like a book on the top right, and then you can thumb through your variables or arrow through them, click through them, and so here you have your set point, and then here you have your modbus register. It comes in here as modbus register offset. This is what you're going to want to use in your gmodbus file. It's important. If you've used a lot of gmodbus in your life, you probably already know this, but you're going to have to offset this by 1. So this set point 1 is actually register 1006. I used modpol myself to figure that out because I find that that's a much quicker tool than restarting gmodbus a bunch of times. And then this variable, you're going to see there's an arithmetic calculation. And so this would be register 1010. Again, that button's right here to get those registers. And then this, just for fun, I decided I wanted to try simulating a pressure transducer with a first order polynomial baked into the virtual variable. So if we click this, this is actually, I mean, you can think of this as a calibrated version of my Gantner AI channel 1 over here. And you can see that because it says V10. And whenever you're using this tool, you can just click the variable and it'll default to putting it in there. So this is my 0 to 100 psi pressure transducer. Exit out of here. So, and then the other important tool, if you haven't used Test Commander much, read online values from controller. We're going to click that so that we can see what these things are. And so simultaneously we're going to look in this terminal. So, well, I should probably start with my spec file. So I created this spec file, gmodbus.gantner. Index is simple IP address, use your IP address. This one, the port, you can get the port. I jumped ahead of myself. Double click this and then host interface data port. This is going to tell you your port. The default port when I was setting it up in Test Commander, and another one in GI.Bench was 10,000. So you can maybe just run with that if you're not sure, but that's what it probably is. So, and then Big Indian. So then we get down to the meat and potatoes of our gmodbus file. Here I've created all these variable names for CyFlex. For what it's worth, I did go ahead and create mine in GenLabels before, instead of letting gmodbus create them, so that I could get a format of 4. So 4 values after the decimal place as the default display format, because that's what I wanted. gmodbus will default to giving you 2, and there's unfortunately no column for you to ask for more. So I used GenLabels to create mine, and then I'm using gmodbus to update them. And so here you've got the registers. Again, you're going to get these from the statistics in Test Commander, and the rest of this is, if it's something that you're wanting CyFlex to update, it's going to be an O as far as an input or output. And that's what's working for me. Intuitively, I would have thought it would have been this, but this is working, so this is what I'm using. You can feel free to experiment with both. And then as far as reading them, I was using read holding register, or I0, because a lot of them were configured as input-output in GI.Bench. It might give you the same if you use just I'm not sure. This is how I set it up whenever I was going through. So the fun part, if we go back to here and then go back to read online values, we can just do a quick comparison and make sure that CyFlex is seeing what this Gantner brain is seeing. And so it looks like I left some of these things the last time I was playing with this. So if I svar Gant AO1 to 0, well, then you'll see that my Gant AI1 also goes to almost 0. You can see some electrical noise in here. And then my 0 to 100 psi pressure transducer is now closer to 0. And then I've got this set point that I set to 1.23 earlier. I can set it to 2.34, and you should see over here my set point 2 is now going to 2.34. And then, yeah, svar Gant AO1 to 4.5, and then now we get 45 psi roughly on my pressure transducer, and 4.5 volts. This is what I directly set with my AO, and then reading in 4.5 volts. And all this kind of correlates with what you see over here. My Gantner AO is 4.5, my AI is 4.5, and then my first order polynomial simulated 100 psi pressure transducer is around 45. The only other thing that's worth pointing out, if we come back over to here, let's exit out of that. So GI.Bench, if you've got something with GI.Bench, this isn't actually my project. This was a project a customer sent to me. It's much easier. It's worth noting, you see that it says that I am licensed. It also thinks I'm an expert. I'm not. But if you have the licensed version, then you can click this export button and then go to export variable info, and then it's going to give you a CSV file. It'll ask you where to save it. I've already got it open, so I'm not going to do it again. But that file is super cool because it gives you all of your modbus registers in one sheet instead of having to click through like that statistics did. And then it's also going to give you your variable types, and then what the variable was, what you named the variable in Test Commander or in GI.Bench, what it's named on the q.station, I should say. And that, in theory, similar to Test Commander, you're going to need to add 1 to anything that you see in here for modbus register. But it should all work that way. So that's that's what I learned playing with this and getting it to work over the past couple days. Again, I just thought I would share it. If you have played with this tool and you have learned different or better things than me, feel free to leave a comment and share with the community what you've picked up. Alright, thanks everyone.